So in question number 12, it says assume that each born child is equally likely to be a boy or a girl. So equally likely means it can be a boy boy or boy girl or girl boy boy girl girl. So equally likely, so the chance of boy is 1 by 2, this is also 1 by 2. Alright, so that's what they mean by saying that this is an equally likely possibility. Okay, if a family has 2 children, what is the conditional probability that both are girls? That is the probability you have to find out. So that is the probability both are girls. That is, E will be G. Okay, so what is given? Given means F. The condition F is the youngest is a girl. Okay, given in case 1, the youngest here is a girl, so it can be a boy girl, considering that the first one is elder, second is younger, or it can be girl girl. Okay, so E intersection F will be just GG. Okay, I should not supposed to put comma here. It is simply GG is both are girls. All right, so what is the probability of P of E intersection F is total number of outputs is 4. So sorry, P of E given F is P of E intersection F by P of F, which is 1 divided by, what is P of F is 2 out of 4. So 1 by 4 by 2 by 4 cancels, you get the answer as 1 by 2. Okay, so that is question number 12 solved. Is there a second part? Yes, there is a second part. It says at least 1. So this is the probability you have to find out still, but the given condition changes. That is, at least 1 is a girl. So it can be, what are the possibilities? BG can be there, GB can be there, or GG. At least 1 is a girl. So what is P of F this time? It is 3 out of 4. And E intersection F, does it remain the same? Where is E? E is GG, and E intersection F is, there is only GG common. Okay, so again this is GG. So P of E intersection F is still 1 by 4. Now P of E given F, this time F is this one, is P of E intersection F. P of E intersection F divided by P of F, which is 1 by 4 divided by 3 by 4, and this cancels. Your answer will be 1 by 3. In the 13th question, there are no values given, but the number, there is no sample space given, but the number of elements in a sample space is given. That is, the instructor has a question bank consisting of 300 easy true or false questions. How many are there? 300 true or false questions. And difficult true or false question, how many are there? 200. Okay, then there are 500 easy multiple choice questions. So that will be easy MCQ 500, and there is difficult MCQ. How many are there? 400. Okay, so the sample space, N of sample space consists of 1400 elements. Alright, so what is E here? E is the conditional probability. If a question is selected at random from the question bank, what is the probability that it will be an easy question? Okay, E is an easy question. So how many such easy questions are there? There are a total of 800 easy questions. Given that it is a multiple choice question. Okay, F is a multiple choice question. Okay, so see, F is a multiple choice question. It's just that it is said that it's only a multiple choice question. It has not mentioned whether it is easy or hard. So total number of elements in F will be multiple choice question consisting of easy ones and the difficult one. So total will be 900. So probability of F is total of 900 divided by 1400, or 9 by 14. Why? Because F says given that it is a multiple choice, given that it is a multiple choice, so these are both multiple choices, so together it will be 900. Okay, now P of E intersection F, simply E intersection F, what will be common? F is a set of all questions that are multiple choice. E is set of all questions that are easy. So what falls under both easy and multiple choice? Only 500. So N of E intersection F is 500, because E intersection F means it is easy as well as it is a multiple choice. Okay, now P of E given F is P of E intersection F divided by, what is P of E intersection F? We didn't find that. P of E intersection L will be 500 by 1400 is 5 by 14. Okay, so P of E intersection F divided by P of F, which is 5 divided by 14 divided by 9 by 14, or your answer will be 5 by 9. Alright? Okay, let's go to the next question. Let's read question number 14 in the reverse order. What does it say? Is given that two numbers appearing on throwing two dice are different. Now we have to find the probability of the event that the sum of numbers on the dice is 4. Okay, so we'll read it from behind. We'll read a second sentence first. That is, find the probability of the event the sum of the numbers on the dice is 4. Okay, so what is the sample space when two dice are thrown? You get 1 1, 1 2, you get 2 1, 2 2, etc. up to 6 6. Okay, what is the event E we have to find out? Find the probability that sum on the dice is 4. Sum on dice is 4. And what is F? F is that given that two numbers are different. Two numbers are different. Okay, so in this sum on the dice is 4. What are the possibilities you get? You get, if you take 1, it will be 3, 2, it will be 2, 3 will be 1. Okay, so there are only 3 possibilities here, and if two numbers are different. Okay, so let's not write all the numbers that are different. Let's think of, let's say there are 36 numbers in total, out of which 1 1, 2 2, sorry, 1 1 numbers should be different, right? So can I take from the total of 36, can I delete all the numbers that are equal, that is 1 1, 2 2? If I delete all such elements, there will be 6 elements gone from this, so F will only have 30 elements. So probability of getting F is 30 out of 36, right? So what is P of what is E intersection F? What is common in both E and F? So F is all numbers where no numbers repeat. Okay, so every numbers are different. So E intersection F means it should be there in both E as well as F. So like I said, F does not have any element that repeats itself, but it has all other elements. E has 1 and 3, which is different. 3 and 1 is different, but 2 2 is repeating. So this cannot be there in E intersection F. So E intersection F will only have 1 3 and 3 1. So what will be P of E intersection F? It will be a total of 2 out of 36, right? Now P of E given F will be P of E intersection F divided by P of F, which is, what is P of E intersection F? Is 2 by 36 divided by 30 by 36, or your answer will be 2 by 30 or 1 by 15. Done. Let's go to question. Is the question clear? Yes. Question number 15 says, consider the experiment of throwing a die. If the multiple of 3 comes up, throw the die again, and if another number comes up, toss a coin. So if you toss a die, what are the possibilities you have? You get 1, 2, and 6. If 3 comes up, you throw this die again, 1, 2, 6. Similarly, here 1, 2, and 6. So what is the probability of getting 1 when 1, 2, etc. when throwing a die? It will be 1 by 6, 1 by 6, 1 by 6. Here also this will be 1 by 6, 1 by 6, 1 by 6 everywhere. Alright. So what if for all other numbers, what do we do? There is a coin tossed. So this will be head, tail, and head, tail. So here the probability is 1 by 2, 1 by 2, 1 by 2. I don't know whether this will be required, but let's see. Okay, so this is the branch you get for this question. So find the conditional probability of the event. So what is E here? Conditional probability of E, which says the coin shows a tail. Shows a tail. So E will show you a tail only when a non-multiple of 3 comes. That is, what are the possibilities in this case when it shows a tail? It could be 1 tail, 2t, 3t will not come, 4t, 5t. This is the only possibility for showing a tail. Now, what is a given condition? F. Given that at least one die shows 3. Okay, if a die shows 3, automatically, if a die shows 3, automatically this will be involved. So 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. When one die shows 3, and what's the other case? Here, when 6 comes, it will show a 3. Alright, so then 6, 3. So what is n of f here? There's a total of 7. If you ask, what is probability of f? So for that, you need to know what is the total number of outcomes. I'll tell you. For 1, 2, 3, and 4, you will get either a head or a tail. So there are 4 elements giving you 2 outputs each. So that will be 8 here. For 3, not 1, 2, 4, 5 actually. Yeah. For 3 and 6, you get another 1, 2, 3, 4, 5, 6. So 2 elements will give you 2 into 6, 12. So there's a total of, what is the total number of outcomes? 8 plus 12, 20 outcomes. I'm trying to tell you that there are 20 outcomes here. Okay, see. 1 will give you 2 outcome, 2 will give you 2 outcome, 4 will give you 2, 5 will give you 2. So that will be 1, 2, 3, 4 into 2, 8 such outcomes. And similarly for 3 and 6. Okay. So P of F will be 7 out of 20. Alright. Now what is E intersection F? What is common in both E and F? F says that 3 shows up at least once. So if 3 shows up, then there is no chance that it will show a T also. So therefore E intersection F is 5, or P of E intersection F is equal to 0. So I think the answer has become so much more easier. So why did I take P of F is equal to 7 by 20 instead of doing 1 by 2, 1 by 2 plus 1 by 2, 1 by 2? How could I directly do it? I could directly do it because all these has equally likely probability. All events are equally likely events, so that I can directly take 7 by 20. But if somebody asks you what is P of E, will you write 4 by 20? No, you can't, because here the probability of getting 1 and T is different. Probability of getting 1 is 1 by 2. Probability of getting T is 1 by 6. So you cannot do that there, but here you can do. I think here also you can do, because yeah, all elements are equally. Okay, never mind. But now P of E intersection F is 0. Now P of E given F is P of E intersection F divided by P of f. That is 0 by P of f is 7 by 20. Never mind. So there is no such possibilities where you can get a coin that shows tail and it shows 3 also. Okay, so I hope this is clear. Right, let's go to question number 16. Question 16 says P of A is 1 by 2, P of B is 0. What is P of A intersection B? So what's the formula for P of A intersection B? It is P of, sorry, not A intersection B, A given B. So P of A intersection B divided by P of B. So I don't know what is P of A intersection B, let it be there. Divided by P of B is 0. Any number divided by 0 is not defined. Okay, next question. In question 17, P of A given B is equal to P of B given A. What is P of A given B? It will be P of A intersection B divided by P of B. Here this will be P of B intersection A divided by P of A. So numerator is anyways same, which means P of A is equal to P of B. Solved.